We've already defined matter. We know that matter is anything that has mass and takes up space. And we named some examples of matter, like your book and you and your pencil, and then I threw out some actual chemical sounding stuff, like hydrochloric acid and sodium chloride. But let's look at how we can classify matter. And there's a diagram of this in your book, but I'm going to work through it here. Matter can be classified as a pure substance, or as a mixture. Pure substances are things like elements or compounds. So what do we mean by that? What are the elements? Well, you know some of them, and in the front cover of your book, there's a periodic table of the elements. And the front cover of your book has the symbols and it has the names, but you need to familiarize yourself with the symbols and understand what their names are. Don't always rely on a periodic table having the names of the symbols there. But there's different elements. There's sodium, Na, potassium, K, gold, Au, helium, He. All these different elements, and those elements are different. We're familiar with gold. Perhaps you have gold jewelry, and maybe potassium. Where do you need potassium in your body? Yes, you do. We get potassium from bananas. But you should be familiar with the different elements. What's a compound? A compound is two or more elements bonded together. Examples of compounds. Water. And you know that water is H2O. Table salt, isn't that sodium chloride? NaCl. And you may be familiar with others as well. Glucose, C6H12O6. These are compounds. It's two or more elements that are bonded together, but it can still be a pure substance. Pure water means that there is nothing but water in that sample. Pure sodium chloride means there's only sodium chloride in that sample, nothing else. Pure glucose means you're looking at only glucose, nothing else. Can compounds be simplified? Can compounds be broken down into simpler substances? Well, yes, compounds can be broken down into elements. They can be separated into their elements. How would that happen? Well, it would require a chemical reaction in order to break compounds down into their elements. Okay, let's look at the other side of our flow chart. A mixture. Well, a mixture, it's two or more compounds. And they don't react together, they're just in a mixture. For example, salt water is a mixture. Dr. Pepper is a mixture. It's two or more compounds. Mixtures can be further classified as homogeneous or heterogeneous. Since I'm running out of room, I'm going to come over here and talk about the difference between homogeneous and heterogeneous. A homogeneous mixture means that it's uniform throughout. It's the same thing throughout its composition. Heterogeneous means that it's not uniform throughout. It would be different. And let's focus on this for a little bit and talk about different examples. I just said that salt water is a mixture. It's two or more compounds. Well, is salt water, do you think, is it homogeneous or heterogeneous? Salt water would be homogeneous. Because doesn't salt dissolve in water? Yes, it does. And so if you had a glass of salt water, it's the same on the top of that glass as it is on the bottom of that glass because salt dissolves in water. What about sand in water? Well, sand wouldn't dissolve in water. So if you had sand in water, wouldn't that be heterogeneous? Because it doesn't dissolve. You might can stir it up and the sand's swirling around in the water, but when that glass sits there, what happens? The sand settles to the bottom. So the top of that glass, the water at the top, and the water sample you would get from the bottom are going to be different. At the bottom, you would have a whole lot more sand in your sample. Therefore, that would be heterogeneous. And see, sand doesn't dissolve in water. When things dissolve in each other, like salt water, that's usually homogeneous. Some other examples. Dr. Pepper, Coca-Cola, those are homogeneous. Because you don't shake it up before you use it, do you? I hope not, or you're going to have a mess when you open it. But the Dr. Pepper at the top of the bottle is the same as the Dr. Pepper at the bottom of the bottle. So that would be homogeneous. Heterogeneous. What are some things you shake up in order to use them? Chocolate milk. Chocolate milk would be heterogeneous. Orange juice. Heterogeneous. Italian salad dressing. Heterogeneous. Okay, so look at that in different ways to classify matter. Would it be pure or would it be a mixture? If it's pure, is it an element or a compound? If it's a mixture, is it homogeneous or is it heterogeneous? Because you want to be familiar with those different classifications. There's some sample problems in your book that can help you with that, because you will see some of these classifications on your quiz and on your test.